Ever tried synchronizing your team's Python notebooks in Fabric only to end up in merge conflict chaos? You're not alone, and you might be missing a core piece of the puzzle. Today, we're mapping the invisible threads connecting Git, Microsoft Fabric notebooks, and every update your team makes. Why does Fabric's Git integration work the way it does? And what's the simple overlooked switch that could save your Lakehouse projects from disaster? Stick around for the practical framework every data team should know. Why Git integration in Fabric isn't just a backup plan. If you've ever thought Git in Fabric is just another way to stash your files, something like putting a backup on OneDrive or SharePoint, think about what's actually at stake when your team starts collaborating on anything that matters. Fabric makes Git a core feature for a reason, even if it looks like extra clicks or extra hassle on your first few projects. The reality is, saving your notebooks or pipeline code in SharePoint might look safe. But the moment you have more than one person making changes, it only takes one misstep, one careless drag and drop or copy paste over the wrong file, and suddenly you're missing half a day's work. Or worse, you're scrambling to rebuild workflows you just finished. Some teams fall into this trap early. Just put it in the shared folder. Everyone can grab the latest copy. Fast, sure, but let's talk about what happens when someone does a quick fix on a notebook, closes out the file, and someone else doesn't realize the change just got overwritten a few minutes later. You've got no idea who changed what or when. Even naming conventions like final versioned edited don't help when you've got 5 people pressing save at once. It's chaos in slow motion. You won't even spot the issue at first. But wait until a subtle change in a data transformation, something as simple as an extra filter or renamed column, slips into production. Suddenly, dashboards break, metrics don't add up, and you're reverse engineering a problem that didn't need to happen. Now, I'm not just talking worst case, all files lost disaster. What's more likely, and honestly more exhausting, is the slow, silent grind of errors that creep in when you don't know exactly what's changed or why. If you've ever played code detective across notebooks or pipelines that look mostly the same except for one obscure setting, you know exactly how frustrating this gets. According to a study by GitLab, projects without proper version control spend about 30% longer catching and fixing basic issues. That's not just overtime. It's delayed launches, scope creep, and entire sprints lost to chasing your own tail. For data teams, where iterative changes are the norm and experiments stack up week after week, that lost time is the difference between fast answers and staring at the backlog. You want a real-world taste? I once saw a retail analytics team working on a seasonal forecasting project. They had tight deadlines. Lots of notebooks, lots of small tweaks across different Lakehouse layers. Because 2 analysts weren't syncing changes, one analyst saved a notebook to their desktop, the other tweaked the same notebook directly in Fabric, and they both uploaded their versions at the end of the day. Guess what happened? The insights from an entire week got thrown out, and nobody even noticed until the dashboards started spitting out numbers that made no sense. Git could have flagged that conflict immediately, naming who made which change, surface the overlap, and force a review before anything broke. That's where the real value of Git-connected workspaces kicks in. Instead of treating Git like insurance, maybe you'll need it one day, you start seeing it as a living record of all the moving parts. Every notebook commit, every pipeline edit, each little change is logged with who made it and why. You're not just saving files, you're building a source of truth and a trail you can trust. Teams aren't left squinting at the most recent upload and hoping it lines up. They see exactly how one change triggered another, and if something goes wrong, it takes minutes, not hours or days, to zero in on the cause. This isn't about being paranoid or getting buried in process for the sake of process. It's about building trust inside the team. There's no need to second guess whether someone made a quick fix that's now hiding in the latest version. There's no playing blame games when a problem rolls in, because the audit trail is open. And when it comes to compliance or even just doing a solid handover to a new team member, Git-connected Fabric workspaces cut out the guesswork. No one has to read through endless email chains or dig through old folders. You just pull up the record, see the diff, and understand the logic in 30 seconds. Best of all, you start shipping solutions, not spending all your time recreating what you lost or debating which version is the right one. Fabric's Git integration brings accountability and transparency without slowing you down. It's not just storing your stuff, it's keeping your work visible, trackable, and resilient in the face of mistakes. That's what teams need, especially as data projects become more complex and cross-functional than ever. So if you're used to thinking of version control as a nice to have, something someone else can deal with, consider how much it's actually costing your projects when you don't have it. Git in Microsoft Fabric isn't just backup, it's the foundation for every workflow you want to trust. And once you experience the difference, there's no looking back. Now let's pull back the curtain on what really syncs to Git in Fabric and which pieces you need to watch more closely. And connecting the dots, how notebooks, pipelines, and Lakehouse sync with Git. You've wired up your Fabric workspace to Git, seen the confirmation message, and maybe even breathed a small sigh of relief. But let's bring some daylight to what's happening below the surface. If you're picturing every notebook, pipeline, and Lakehouse asset now basking in the protective glow of version control, it's time for a reality check. Git in Fabric is powerful, but it isn't magic. Some items sync effortlessly, others are left out of the loop entirely. It's these blind spots that tend to cause the headaches that show up days, sometimes weeks after you think everything's covered. The most common misconception I hear is this. Teams assume connecting to Git means their entire data universe is now safe, trackable, and recoverable if something goes south. It's not that simple. There are categories in Fabric that play nicely with Git right out of the box. Notebooks, especially Python ones, are tracked without extra effort. Data pipelines generally show up in your repo, and any tweaks to their logic parameters or even scheduled triggers are versioned from the moment you hit save. This covers the building blocks where code lives, transformational recipes are tested, and logic evolves over time. All the collaboration features, commit history, and who did what transparency you expect from Git, you get them here. But what about Lakehouse tables or the actual data sitting inside them? Here's the piece that trips up even experienced cloud engineers. Fabric's Git integration is code first. By design, it only tracks metadata like scripts, pipeline definitions, and configuration files, not the gigabytes or terabytes of raw business data that get produced, shuffled, or modeled every day. So you might notice your notebooks and pipelines happily showing up inside the IPAN or JSON files in your repo. Start looking for your Delta tables, Parquet files, or schema changes directly logged in Git, though, and you'll run into a wall. Those tables don't take instruction from Git. Data itself continues to live and evolve inside the Lakehouse, and there's zero version history for it in your source control unless you layer on extra tooling or manual snapshots. Think about a team of developers all building inside the same workspace. One person is refining a notebook's logic, another is tweaking a pipeline to speed up processing, and a third is over in the Lakehouse interface making changes to storage settings or updating a schema. If the team isn't fully clear on what's Git tracked and what's not, subtle confusion can build. Everyone moves fast, assuming every step is protected. Yet, if someone rolls back a notebook after a failed sprint, the code jumps back as expected, while the corresponding data might end up ahead or behind what the pipeline was expecting. Now you've got mismatches, silent errors, or even data drift. The result? Debugging sessions where everyone's out of sync, not just technically, but also in how they think the workspace should behave. It sounds academic until you've seen it happen. I once watched a finance analytics team stage some tricky pipeline refactoring over a long weekend. They nailed the code changes, committed every notebook edit, and even kept their feature branches neat and tidy. But when they deployed, dashboards showed last year's numbers in the new reports. Turns out one analyst had refreshed a set of Lakehouse tables manually, while another was rolling back pipeline steps using Git. The pipelines and notebooks were synced. The business data wasn't. It took almost a full day to trace that split because everyone was assuming Git had their backs on absolutely everything. It's not just about near misses either. Microsoft's own documentation spells this out if you scan for the fine print. Fabric's current Git integration covers notebooks, data pipelines, data flows, and semantic models such as Power BI datasets or reports. Anything that's basically code, configuration, or metadata fits. The wildcards are assets like managed tables, physical data sets, and certain types of connection objects. These aren't linked to Git's version history. You end up with a split brain environment, part of your solution archived and diffable, the rest running parallel without any checkpoints. Visualize this mess like a subway map. Your notebooks, pipelines, and data flows join the main line to Git Central. Each transfer, each edit, traceable from start to finish. Then there are the Lakehouse tables chugging along on a line that never even meets the Git station. It's organized on paper but disconnected in practice. Unless you pause and design around these boundaries, you will eventually promote new code that assumes data is in one state when it's actually somewhere else entirely. So what does this mean for your day-to-day workflow? Start by always knowing what assets are actually Git synced. Resist the urge to treat your entire Fabric workspace as a single unified project when it comes to source control. Build processes and checklists that double-check non-versioned assets before moves between environments. If there's manual intervention needed, document it so no one's caught off guard. Fabric's Git connected workspaces are your audit trail for code and logic. But for datasets, there's still a reliance on discipline, documentation, and sometimes old school backups. Understanding these boundaries is how you avoid those 2 a.m. surprises, the ones where a rollback fixes the code but quietly breaks everything downstream. Lean into what's actually protected and factor in the rest. Now, you might think connecting a workspace to Git will iron out all these details for you, but what actually happens once you flip that switch is a bit more complicated than hitting sync and walking away. The hidden dynamics. Connecting workspaces, handling conflicts, and branching for teams. So you finally hit the connect to Git option in an established Fabric workspace. Now what? This moment always feels a bit like turning the key on a machine you didn't build and just crossing your fingers that none of the gears grind against each other. The reality is, linking Git to an existing set of notebooks and pipelines is far from just another sync operation. What actually happens and what you'll deal with next doesn't always follow the perfectly smooth onboarding that documentation suggests. Let's start with what Fabric is really doing behind the scenes. When you connect to Git, it doesn't just take your workspace and wrap it in a version control blanket. Instead, every notebook, pipeline, data flow, or semantic model is checked against the state of your chosen Git branch. If there are items in the workspace that never existed in the repo, or files in Git that were changed in parallel to what's live in Fabric, you could immediately be walking into merge conflict territory. For teams that have let everyone work solo for too long, this means you open the door to a whole lineup of out-of-sync notifications. I've seen it happen frequently. You connect Git and Fabric suddenly flags half of your notebooks with alerts or demands for manual resolution. At this point, it's less about version control convenience and more like cleaning up after a quiet storm of overlapping edits nobody realized were brewing. One detail most people gloss over. Fabric treats your Git repo as the single source of truth once the connection is made. This means any differences between workspace assets and your chosen branch get put front and center. No hiding, no I'll fix it later. If team members have been updating notebooks or tweaking pipelines without coordination, prepare for a lineup of merge conflicts staring you in the face. Unlike a more traditional file share where last save wins rules by default, Git inside Fabric wants real agreement. You'll need to decide whose changes get priority, what should be rolled back, and what needs a careful line-by-line merge. There's no skipping this step if you actually want version control to function the way it's supposed to. Take a classic real-world problem. A new team lead gets the green light to bring source control to a busy workspace. They finally connect to Git and immediately face a wall of red flags, dozens of notebooks flagged as out of sync. Now they're stuck sifting through commit histories, figuring out which update actually fixed the last reporting bug and which ones need to be migrated or discarded. If you've never handled a merge conflict in a fast-moving data project, you'll quickly learn that it's more than a technical challenge. It's also a test of team patience. Some people start worrying about their changes disappearing. Others push back against the process because it feels like needless overhead. It's the data equivalent of traffic merging into a single lane. Everyone's progress slows until the roadblock clears. This is why a straightforward branching strategy isn't just a nice to have, it's how you stay sane. In the early stages, it's tempting to keep everything on one branch, the infamous main or master, because simplicity sounds easier. But the cracks show up fast, especially as more analysts, engineers, and stakeholders want to make edits, trial new features, or fix bugs. Many teams survive their first conflict and decide to keep separate branches for experiments, often called dev or feature branches, and a protected, stable main branch for work that's finally ready for broader review or deployment. The sweet spot is usually 3 levels: main, production, dev, testing and experiments, and then one-off branches for specific features or bug fixes. You avoid the worst pitfalls of both chaos and bureaucracy. But don't get carried away with complexity for its own sake. Every extra branch you invent is another source of confusion unless there is a clear way to review, approve, and merge changes. In practice, dragging out endless reviews across a dense web of branches means nothing gets released. The research backs this up. Overly elaborate branching models tend to slow down data science teams instead of making things safer. Keep it simple enough that everyone remembers how to move their work forward without tripping over each other. And here's a bit that often gets missed. Handling conflict isn't just a technical question. Merge disputes fuel office friction, especially when people worry their hard work is about to be replaced, overlooked, or tangled up in someone else's mistakes. If you don't plan for this upfront, by setting rules for who reviews changes, how conflicts are flagged, and who has the last word on merges, conflicts become political, not just practical. I've seen projects grind to a halt because no one wanted to be the person to reject a colleague's update. Teams that plan their process up front, deciding how to name branches, who reviews merges, and how to resolve disputes before going live, spend far less time fighting fires later on. The last benefit here is time. The teams that invest even an hour to lay out their branching and conflict handling process spend drastically less time in postmortems and last-minute patchwork. Suddenly, version control is freeing, not frustrating. And with this structure, you can start thinking seriously about how to use Git branching in Fabric to handle different environments and make sure a fix that worked in dev actually makes it safely to production. Scaling collaboration, environment management, branches, and real-world best practices. If you've ever found yourself wondering why a perfectly good notebook works in the dev environment but falls apart in production, you're not seeing ghosts. You're seeing the fallout from missing environment management. It's one of the most common, quietly expensive problems inside data teams working with Fabric. You get a model humming in dev, maybe even a few passing outputs and demo dashboards, but as soon as you try to promote that work to production, something breaks. The formulas chew through their inputs, but now you're getting strange errors, missing columns or metrics that veer off into the weeds. Most teams react in the moment, quick patch, maybe copy-paste everything over to prod, and hope for the best next time. Before you know it, you've got your own Wild West. Code floating between environments, undocumented fixes, and everyone a little afraid to touch anything. Let's put the problem under a microscope. Data teams usually understand the need for environments. After all, you wouldn't run an experiment on production tables given the choice. But translating that principle into an actual process is where it falls apart. In Fabric, the temptation is to hustle notebooks or pipelines between workspaces using manual exports, file uploads, or worst of all, direct edits in production. That manual copying quickly creates gaps. It's all too easy to overwrite something important, miss a parameter update, or forget about a dependency. Over a sprint or two, this snowballs. Someone's bug fix goes missing during a promotion. A notebook works in dev because the data was staged differently. And nobody realized the production Lakehouse wasn't quite synced. You're fighting fires instead of building pipelines. This is where Git branches step into the spotlight. Instead of pretending manual promotion will ever be truly safe, you make the environments explicit. Each branch stands for a different state of the world. Your dev branch is messy, experimental, perfect for rapid notebook edits, half-baked ideas, or architectural changes you're not ready to stake a release on. When something in dev is ready for testing, it gets merged into a test branch. Here, you can validate, peer review, and spot mismatches before anyone in production ever sees the update. Promotion to main or production is a deliberate action. It's not a matter of copying files and hoping they're coming through the same pipeline your team relies on every day. Picture a pipeline that gets constant tweaks in dev. Maybe you're optimizing a join, swapping in a new data source, or just cleaning up the code for readability. Dev is your playground. The moment you move that code to test, you see how it runs against more representative data, catching weird edge cases or revealing assumptions that only show up on real data. If something breaks or another team member flags an issue, it never leaks to production. You fix things in test, rerun your notebook, and only when it passes all the checks does it progress to main. That's how you turn source control into a true safety net, not just for backup, but for process. Problems are spotted early, usually by the people who introduce them, not by the end users or business leads who just want reports to work. But here's another twist. Not every asset in your Fabric workspace will follow along for the ride. It circles back to the Git boundaries, especially when it comes to Lakehouse data itself. Your code, pipeline configs, and even some semantic models march through the Git branch process. But the tables and raw datasets remain untouched by Git. This isn't a small footnote. It fundamentally shifts how you think about parity across environments. You can have pristine versioned code and still find that prod gives you headaches because the data has drifted, staging lags behind, or someone ran a manual update early in the process. Relying on Git alone won't save you from all the classic "it worked on my machine" moments. You need separate checks and routines to validate datasets and keep staging and prod tables aligned. That's not theoretical. I worked with a finance team tracking monthly ledger updates across regions. They lived in constant fear of overwriting production work. So they finally set up Git branches the right way: dev for daily experiments, test for validation, and main only for releases. One week, a bug slipped through, a logic error snuck into a financial transformation notebook. Instead of scrambling to fix it in prod, they used Git's history to roll back swiftly. No rework, no manual file hunting. They kept going because their branching model gave them the space to test, review, and trust their release process. So how do you maximize this model without weighing your team down? Keep it focused. Experts point out that simple structures last. Too many branches create confusion. 3 levels: dev, test, prod cover most real-world needs. Use pull requests for every merge to a stable branch, and require at least one peer review. The social pressure here is healthy. It slows you down just enough to prevent mishaps. When you can layer automated tests into those pull requests, catching broken pipelines or missing dependencies before they get merged. In Fabric, this looks like test notebooks, simple data validations, or dry run previews. Not just code review, but lightweight automation that catches obvious errors. Teams that follow this discipline, light but deliberate branching, pull requests, and just enough testing, see fewer failed deployments and recover faster. You're not building bureaucracy, you're building habits that free your team to move with confidence. When a problem does sneak through, it's a matter of reverting a commit, not tracing back 100 manual file copies scattered over email or chat. That's how you start converting Git in Fabric into not just a technical tool, but the groundwork of a solid future-proof data culture, one where process protects both your team and the data you're trusted to deliver. And once you taste that resilience, rolling out smarter, safer workflows becomes second nature. If you've tried to memorize every step and still run into issues, it's probably not your fault. The reality is, managing Git in Fabric isn't about ticking boxes, it's about shaping habits and expectations so your team can move fast without getting burned. Version control should never just be a check mark at the end of a checklist. When your team maps out how work moves, who reviews what, and how you recover from mistakes, Git becomes a guardrail, not a bottleneck. The teams who invest in this see fewer headaches, more predictable releases, and a lot less detective work when problems pop up.